Hey guys, Mrs. Traver here. We're going to do our notes on solving square root quadratics. And we're going to start off with one that looks similar to the ones we've done before, where we did the Lizzie method and the British method of factoring by grouping or with our magic math methods and stuff. So here's one that looks similar to what we've done before. Our first step always to look is always to look for a greatest common factor, and we have one here of 7. So if I were to do that, I would have 7 times the quantity, x squared minus 5. This is going to end up being one where something different happens, and I'll show you a different way of how to solve it with these square roots. So if I was going to try to do this one, I could think of it as x squared plus 0x minus 5. And if I was going to try to factor this out and find factors of 5 that add to 0, there are no 2 factors of 5. First off, 5 is prime, so the only factors of it are 1 in itself. And if I were going to use those, it's not going to add to be 0. So at the point we were at before, this is not factorable. And I made a point before when we talked about ones that are not factorable, is it's not that you can't solve it, it's just that you can't solve it by factoring. We're going to solve this a different way. So if I wanted to solve this guy, let's instead, let's try to solve for x by getting x by itself. Let's add the 35 to the other side. And then let's divide out our 7. Let's get our x squared term by itself. So x squared equals 5. If I want x by itself, I need to do the inverse of whatever is happening to it. So right now it's being squared. In order to inverse that, we need to take the square root of both sides. That way those cancel. And I'm left with just x on the left. And on the right, I have square root 5. And we need to be careful here to add a plus or minus sign in. Because keeping in mind, if you have something squared, it could have either been 5 times 5 or negative 5 times 5. So we've got plus or minus the square root of 5. So if I try to factor this, it would have had to be x plus root 5 and x minus root 5, but you would have never came to that conclusion by trying to factor. Let's do another one. All right, on this one, we've got 3x squared minus 36. Let's get the x term by itself by adding 36 to both sides first. And then divide out your coefficient. From here, let's take the square root on both sides like we did previously. So I've got x is equal to plus or minus the square root of 12. On our last section, we looked at simplifying square roots. So let's do that here. 12 can be simplified into being 3 times 4, and 4 is a perfect square. So let's rewrite this as 4 times 3, and then let's rewrite that again as plus or minus 2 squared times 3. So now it's really obvious what we need to pull out. We're going to have plus or minus 2 root 3. So there's my 2 answers. It's the positive 2 root 3 and the negative 2 root 3. We still have 2 answers to our equation. So there's my answer on this one. In my next one, I've got x squared over 20 plus 8 equals 15. I want to get my x squared term by itself, so let's subtract 8 and then multiply by 20. Multiply both sides by 20. I've got x squared equals 140. From here, square root both sides and add our plus minus. And then do what we can to simplify this square root. So let's try to find the prime factorization of 140. And sometimes it's nice to do this off to the side, by the way. So I've got 70 times 2, and that's 35 times 2, and that's 5 times 7. And I know I'm done when I'm left with all prime numbers. And you can get to this in several different ways. So this looks like 2 squared times 5 times 7. So I've got, I can pull out a 2, and then in the inside I'll have 35. So x equals plus or minus 2 root 35. In our last example, let's do one that involves some fractions. I've got 5x squared over 6 minus x squared over 3 equals 72. It'd be nice if I could combine these two as like terms, but right now their denominators are different. So let's make this guy be a 6 by multiplying by 2 over 2. So we're multiplying by a special version of 1. So then I've got 5x squared over 6 minus 2x squared over 6, which I can add these two on the top or subtract them. So 3x squared over 6 equals 72. And let's get rid of our denominator, multiplying both sides by 6. So 72 times 6 is 432. Let's get rid of our 3, divide both sides by it. X squared equals 144. And then square rooting, I've got x equals the square root of 144, or plus or minus. This is a perfect square, so x equals 12 and negative 12. All right, so we've walked through a few examples of these guys. I think we've covered a little bit of all of them, but with square root quadratics, if you try to start off, you would have ended up having something that was not factorable, mainly because each one of these, notice there was no term where there was an x on it. There was only x squared terms and there were c terms. But if that's the case, then you kind of should have a red light going off that you are probably in a situation where you were in a perfect situation for solving with square roots. So hopefully these notes have helped, and we will see you next time.